Okay, so today what we're gonna work on is trigonometry, right? So this is one of the big topics on the CSEC maths exam. So this one, along with geometry, is worth 21 marks. So the first one we're gonna look at is the Pythagoras Theorem, which we're gonna use to calculate the missing length of a right angle triangle. So it only works for right angle triangles. It has to be a right angle triangle. Then we're gonna also look at trigonometric ratios. That would be like sine, cosine, tangent, and so forth, to calculate a missing length or angle of a right angle triangle. All right, so say we have the Pythagoras theorem, right? So what the Pythagoras theorem basically says is that c squared is equal to a squared plus b squared. That is the formula for Pythagoras theorem, and it's for right angle triangles, right? So what this is saying, that c here represents the longest side. Okay, and this longest side is called the hypotenuse. The hypotenuse. So we could say that this here can actually be labeled as C, referring to the hypotenuse. So this here represents the hypotenuse. Now, the lengths A and B represents the other two sides, which we refer to as a shorter side. So this is the thing now. When it comes to these, any one of them could be A or B. So this could be A, this could be B. All right. However, the hypotenuse has to be C. It has to be C. Now, the hypotenuse. What is the hypotenuse? The hypotenuse is basically the line that subtends the right angle in a right angle triangle. So, when we say subtend, we mean like it closes. Okay? So you see this here. This is a right angle here. Now pretend I had a cloud closing this angle. So this cloud closes the angle. You follow me? So in other words, this cloud subtends or closes the right angle. So likewise, the hypotenuse is the line that closes the right angle. Okay, so this here is the hypotenuse, opposite of the right angle. Now the Pythagoras theorem is used to calculate the missing length when you have two known lengths of a right angle triangle. Okay, so once you have two known lengths, it can help you to find the other length, but it has to be for a right angle triangle. There are cases when the triangle, you might want to find a perpendicular height. You can use Pythagoras theorem for that as well too, but in order to use Pythagoras theorem, a right angle must be involved. All right, so we'll do an example of calculating using this. So I'll say scenario 1. So we say for this scenario is the unknown hypotenuse. All right, so let's say we had a right angle triangle here. So we know what this length here is. Let's say this length here was 6 centimeters, and this one over here was 8. So we have 8 centimeters over here. Now the question is, what is missing? The missing one is the hypotenuse. All right, so in that case, using the formula, we would say c squared is equal to a squared plus b squared, where c is what c represents? Hypotenuse. Excellent. Now if this is c and we are looking for c, then any one of these could be a and b. All right, any one of them could be a and b, because the only one that has to be what it is here is c, which has to be the hypotenuse. So 8, I could say 8 is a, or I could also say that 8 is b. So I'll just say 8 is a, and I'll say 6 is b. So all I need to do is go back to this formula and substitute. So I'll have c squared is equal to a squared. So what is a? 8 centimeters, right? So we say 8 squared plus, what is b? Yep, that would be 6 squared. Excellent. So what does that mean? What is 8 squared? What does that mean? 8 times 8. So what's 8 times 8? 64. And then we're going to add that to 6 squared. What is 6 squared? 36. So what can we do next? We could add those two. So then 64 plus 36 is what? 100. Now we have a little problem here. This says c squared. So how do we calculate c and y? Square root of 100. So why did you find the square root of 100? Exactly. So the square root of 100 would be 10. So we know that this here is 10 centimeters. So here is 10 centimeters. Now, the reason we did the square root is because that's the opposite of squaring. The opposite of addition is subtraction. What's the opposite of multiplication? Division. That's correct. So the opposite of squaring is square rooting. All right. So take this down, and then we look at scenario 2, and that's when the shorter side is unknown. One of the shorter sides are unknown. All right, so scenario 2, unknown short side. So for this case now, we're going to use the same triangle, but this time we're going to make one of the short sides unknown. So we already know what every side is. So I know that this is 8. So I'm going to say, let's make this 8 centimeters. And we don't know what this is going to be here. We don't know what this is, but we know it's supposed to be what? What is it supposed to be if we're using the same triangle? 6 centimeters. And here is 10 centimeters. Now, in order to use Pythagoras theorem, I must have two known lengths, and it has to be a right angle triangle. Then I could use that to find the missing length. If I don't have the two lengths and I'm using Pythagoras, I'm only going to get a algebraic expression. All right. So in this case, I want to use this to find this short side. How do I know it's the short side? It's not a hypotenuse. It could have been this one. That's also a short side. Once it's not the hypotenuse, I refer to it as a short side. So I have c squared again, which is equal to a squared plus b squared. Now the question is, what is c? So c is the hypotenuse. So I know that here is c. So I could label this as c. Now remember, we could label this either a or b. It's really up to us. So do we want to call this a or b? Which one we want to call this one? Let's call it b this time, since we use it as a last time. I just want y'all to see that it doesn't really matter, right? So if this is b, that means what I'm trying to find is what? The a. So c squared. So in this case, we're trying to find a. So the value of c is what? What's the value of c? 10 centimeters. So I can put here 10 squared, which is equal to a squared plus what? B squared. And what's b? 8 squared. Right. So 8 centimeters squared. Now I could work out some values here now. So what is 10 squared? What is 10 squared? 100, because that's 10 times 10. So we have 100 is equal to a squared. And then we add that now to, what's a squared? What's 8 squared? 64. 64. Now, this is where things get different now. So in order to solve for a squared, or a rather, we have to get this here by itself. Now in this scenario, to get rid of this 64, we have to do the opposite. So right now it says plus 64. What's the opposite of adding 64? Subtracting. So to keep the equation balanced, we're going to subtract 64 from both sides. So it's like I'm saying minus 64 here and minus 64 on this side. Okay? So if I say 100, I'll have 100 minus 64, which is equal to a squared. But check this out now. 64 take away 64 is what? 0. So that is no longer there. So I'm just left with a squared on this side. Do you see how I got the a squared by itself? Yeah, another way of looking at it is that we usually say if this is positive 64, and we bring it on the next side of the equal sign, it's going to turn from positive to negative 64. So therefore, we're going to end up with 100 minus 64. Everybody understand this part? Yeah. All right. That's the most challenging part of this phase. Okay? Now, what's 100 take away 64? 36. Starting to sound familiar now? So then we have a squared. So what's the opposite now? What do we have to do to get the a? Find the square root. So we're going to say square root of 36 is equal to a. So what can I say a is equal to? 6 centimeters. All right. So that's how we calculate for scenario 1 and scenario 2. All right, so whenever you use Pythagoras theorem, you're going to end up using one of these scenarios, either scenario 1 or scenario 2. You use scenario 1 when you have to find out what the hypotenuse is. So the hypotenuse is unknown and you need to find that out. In scenario 2, it's going to be when you want to find a short side. So that means you have the hypotenuse. All right. So in order to use Pythagoras theorem, remember, we must have two known lengths. All right. And it must be a right angle triangle. Right. So that's what we need in order to use this. All right. So I'll give y'all two to try. So y'all got this, right? All right. So I want y'all to calculate these two lengths here. So this unknown length here and this unknown length here. Now be careful. Remember, we have to know which scenario we have to use. So while you go through this, assess it, and then after you'll have a better idea as to what you need to use. All right, so take a shot at it. All right, so I want somebody to guide me through the first one. What do we have to do? What are we using here? So we're using Pythagoras Theorem, which is c squared is equal to a squared plus b squared. So what are we looking for? The hypotenuse. Excellent. So we are looking for the hypotenuse. So I can say here is c, which is unknown. Which one here represents a or b? N1. Excellent. So I'll say the 5 is a and the b is 12. So now I can substitute. So c squared. So I'm going to have c squared is equal to, replace this a with this a, which is 5 squared, plus b, which is 12. So 12 squared. So therefore I'll have c squared is equal to 5 times 5 is 25 plus 144, because 12 squared or 12 times 12 is 144. So then I'll have c squared is equal to 25 plus 144, which is 169. So then what I can do is find the square root, because that's the opposite of squaring. So I'm going to do that, which is c now is equal to the square root of 169, which is 13 centimeters. All right. Everybody got that answer? Nice. Yeah. Sweet. All right, so the next side here now. Next side. So we're using Pythagoras Theorem again. So we have c squared is equal to a squared plus b squared. C squared is equal to a squared plus b squared. So what is c? Do we have a c here, or do we have a hypotenuse? What is the hypotenuse?
5 millimeters.
So 5 millimeters. I like how y'all using your units. Love it. So this here is c. So this 5 is c. And these here could be either a or b, right?
Yeah.
All right. So let's say this is a and here is b. Okay, so then we have 5, which is c, or the hypotenuse. So I can say here 5 squared is equal to 4 squared plus b squared. So 5 squared is 25, which is equal to 4 squared, which is 16, plus b squared. Now with the b squared, I want to get the b squared by itself. So what do I need to subtract from both sides? The 16. That's correct, the 16. Okay, so then I'll have here now 25 take away 16, which is equal to b squared. Now what is b squared? So 25 take away 16 is 9. And 9 is equal to b squared. Now, what do I have to do to figure out what b is? The square root, right? So the square root of 9 is equal to b, and the square root of 9 is 3. So 3 millimeters would be my answer for b. So here is 3 millimeters. All right? So my answer is 3 millimeters. Does that make sense?
Yeah.
Good. So everybody got that?
Yeah.
Sweet. All right. I see when y'all finish y'all sending. That's good. And don't forget the units as well. All right, so the next thing we want to look at is the trigonometric ratios. So this is when we have to find, for instance, an angle of a right angle triangle, or missing length when we have a length, one length, and an angle. So Sohcahtoa. So what Sohcahtoa represents is basically formulas. All right, it represents formulas. So each one here is its own formula. So from here to here is one formula. Here to here is a next formula. And here to here is a next formula. So we're using 3 trigonometric ratios. All right, so the first one we call it sine, but it's written like sin. This is how it's written. So it's basically sine of the angle, which we're going to understand how to use that and put that in a calculator, which is equal to O for opposite. So O for opposite, which is this O here, over the hypotenuse, which is this H here. So as you can see here, this here is the formula. So sine angle is equal to opposite over hypotenuse. So then the next one is called cosine. So cosine written like this, you'll see it on your calculator just like this, COS. Now, this here is cosine angle. So the formula for this would be A, or adjacent, all right, over hypotenuse. So sine is O over H, which we have opposite over hypotenuse. Then we have cosine, which is A over H, which we have here. What do you think T is? So T represents tangent, but it's written as tan. What do you think the formula for this is going to be?
Opposite over adjacent.
Lovely. So opposite over adjacent. Remember, this kind of like soca music, you know, like soca. So you see how we have SOCA, but we just have that extra H. So if I was to take this out, we have soca. Okay, so just imagine spelling the word soca or soca music with a H. And then we have Toa. So Sohcahtoa. That allows us to remember these formulas. All right, so we know that sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. So the question is now, how do we know when we use these? Now, for now, I'm just going to do it generally speaking, and as we develop this lesson, you're going to see how we use it better. But for now, what I want you to understand is when you have the combination, which one do you use? So for instance, if I have an opposite and an adjacent, which one would I use? Sine, cosine, or tan? Opposite and adjacent. Tan. Why? Because tan has opposite and adjacent. Which one we would use if we are using opposite and hypotenuse? So O and H. Sine. Excellent. Because O and H is associated with sine. What if we have an adjacent and a hypotenuse? Which one we're going to use?
Cosine.
Cosine, because cosine is associated with the adjacent and the hypotenuse. So y'all understand how I use this Sohcahtoa slang in order to determine which one works with what? All right, good. So let's talk about what these things are. We have three different things here. We have the hypotenuse, we have the opposite, and we have the adjacent. So let's see what all three of those represent. The hypotenuse is a line that subtends the right angle of a right angled triangle. So let's say we had a right angle triangle here. So we know this is a right angle here. So therefore, which one of these would represent the hypotenuse? This one right here. All right. Does that make sense? We just transferring the knowledge from the previous one. All right. So the opposite is basically the line opposite to the angle of focus. So let's say we had this particular right angle here. This is a right angle triangle, and these work for right angle triangles. So let's say we had an angle of focus here. So this is the angle of focus, which we refer to as theta. It's a Greek letter. So this is theta. So the line opposite to that would be this. In other words, the line that subtends this angle here, or closes this angle, is the opposite. So right here is the opposite. So this particular line here is the opposite because my angle of focus is this here. This is the angle I'm looking at. Does that make sense? For this concept, right, I'm going to use the exact same triangle. Okay? The exact same triangle. So I'm going to change now my angle of focus and make it up here. So because of this, my opposite is now where? The bottom line. Excellent. So right here becomes my opposite. So this bottom line here is my opposite. So if this is the opposite, this here is the hypotenuse, that must mean that the other line is the what? The adjacent. Excellent. All I need you to remember when it comes to the adjacent is that it's the other line. Once you figure out what a hypotenuse is and opposite, that only leaves one more thing, the adjacent. So basically, all I need you to remember that the adjacent is the line that's not the other two. Okay, so if you know what the others are, you know what the adjacent is. So let's use these here as an example again now. So let's say our angle of focus is here, and we have here now a line that is called the what? What is this line here called? The hypotenuse. What is this one here? This is the opposite. Okay, so this one over here is the opposite. So what is this bottom one then? The adjacent. Does that make sense? All right, good. So let y'all take this down. And once you take this down, I'll give you some to try for you to identify whether This line is opposite, whether that's a hypotenuse or the adjacent. Okay, so we basically gonna be labeling it just like this. So far, everything that we're doing making sense, right? We need to understand these basic stuff before we know how to use the formula. Once we know how to do these basic stuff, then we can talk about the formula. We could go to the first one, and then after give y'all the rest to do. We'll do this one together. I y'all think you can handle it on your own? Which one? Say again? Alright. So, first one. I need to identify hypotenuse, adjacent, and opposite. So, based off of this, what is this line here? Hypotenuse. So, I can call that H. What about this line here? How do you know it's the opposite?
Because it's opposite of theta.
Exactly, it's opposite of theta. So, therefore, here is the opposite. So, if that is the opposite, what is this line here? The adjacent. Anybody did not understand that? All right, sounds like we good. So I'm going to change the orientation and see how you handle it. But it does not matter how I change the orientation. The concept remains the same. So this here is the first skill that we need to understand in order to use those formulas that we looked at earlier. All right, so identify the opposite, hypotenuse, and adjacents of the following. So, tell me, what is this one here?
Adjacent?
You sure?
Yeah.
What makes you say it's adjacent?
Teacher, I just guessed.
You guess. So tell me now, what makes something a hypotenuse then?
Hypotenuse is the line that subtends the right angle.
Okay, exactly. So which one here subtends the right angle? This is a right angle, so if it's subtend or closing it, it would be this one here. You see?
Okay. Mm-hmm.
So opposite of the right angle itself is the hypotenuse. I know it sounds crazy using the word opposite there, but once it's opposite of this here, the right angle, we call it the hypotenuse. Does that make sense?
Yeah.
You got it now, right?
I think so.
All right, so what about this one here? So this line over here would be called the what? The opposite. Okay, good. So how you know this is the opposite?
Because it's opposite to the beta.
All right, it's opposite to the theta or the angle that we focusing on. Okay, so likewise, the hypotenuse is opposite to the right angle. Does that make sense now?
Yes.
So therefore, if this is the hypotenuse, what is this line here?
Adjacent.
Adjacent. Nice. All right, tell us now. This line here represents what? The hypotenuse. Yeah. So this here is a hypotenuse. You follow now?
Yeah.
So then what would this line here be now? This line here.
Teacher making me nervous.
This is how you learn. This is how we gotta learn. You know, you gotta be put on the spot sometimes to force you to understand. You know, that's how we learn.
Okay, so no, that's the opposite.
Tell me why is the opposite. So the opposite, the angle will be the opposite always. And the opposite of the corner is a hypotenuse. So therefore, this part here would be what?
The adjacent.
Adjacent. Excellent. Okay, everybody got that? Okay, good. So again, tell us now. So this one, think about it now. Tell me which line you want to look at first.
So we're going to start from the bottom. And that's going to be the opposite.
Okay, so it's the opposite of this angle here, right? So this is the angle of focus where theta is. So the opposite of that is here. Okay?
Mm-hmm.
Good. Next. What about this line here? What this line is?
So we're doing the little X.
Mm-hmm.
And it would be opposite the angle in the corner.
All right. Now you're talking. So that little opposite line here from this is the hypotenuse. Does that make sense?
Yeah.
So what this here is now then?
Adjacent.
The adjacent. Nice. So y'all got that? Yeah? All right. So I'll give you one now too. This is how you learn it. You know, you got to be put on the spot. And it is force you to think about it, right? So which line you want to do first?
The opposite side.
So which one is the opposite?
Right above it. Yeah, right here.
This? So how you know this is the opposite?
Because it's opposite to the theta sign.
Okay, good. All right. So that's basically our angle of focus. So what else you want to do next? What you want to do next?
The hypotenuse
Okay, which one is that?
is the line right here.
We're here or here?
Above.
So the one at the top. So remember, this is a right angle triangle, and what's opposite of that? You see? Good. So then this one gonna be the adjacent. So if you watch it now, the opposite of this angle that we're looking at is the opposite. The opposite of the right angle is the hypotenuse, which means the last line is the adjacent, right? Same thing here. The opposite of this angle that we're looking at is the opposite. The opposite of the right angle, therefore, then is the hypotenuse. Make sense?
Yes.
And once we know what those are, that means that this one has to be the adjacent. All right? You follow now?
Yes.
All right, good. So, before we go into actual calculations of this now, we need to understand now how to use this part of the formula. Because this part of the formula now, we need to know how to use this. Okay? So this is called a trigonometric function. So we have three functions here, the sine, cosine, and tangent. There are others as well too, but these are the ones that we are going to be looking at. And then we're going to need to know how to do the inverse of that function. All right, so one gives us the trigonometric ratios, the other one gives us the angles. So we're going to go through those ones, how to use the trigonometric function and its inverse. All right, so we need to know how to use it on a calculator. Once we understand that, we're going to combine everything here and actually use these formulas. So at our level, we need to ensure that once we're doing this, we want to ensure that our calculator is in degrees. So depending on what calculator you're on, it's going to show you DEG or D. Okay, so if you look at the corner of your calculator, you should see it. So that D, when you're doing your calculator, it should have that D here as well too. You see how this one has DEG on it?
Yeah.
So right here has DEG. So y'all calculators got that? Alright, good. So to test it, what I want y'all to do is press sine and then 30. Once you press sine and 30, your answer should give you 0.5. If it does not give you 0.5, that means your calculator is not in this form. Okay? So let's use that as a test. Y'all got 0.5?
Yeah.
Good.
Yes.
If you didn't get 0.5, you would have to set it to degrees. Alright, so some calculators you have to put it, you have to press the degrees first, like 30, then sine. So you got to just understand which one your calculator is. All right, so let's try the ones with the trigonometric functions. So for instance, sine, and then we'll say 60. So what we usually do, we try to write these here to 3 decimal places, especially when we're trying to work out the questions. We try to put them to 3 decimal places. So these here would be the trigonometric functions, which gives us the trigonometric ratios. All right, so these give ratios. All right, let's try sine 60. Sine 60. So you see this one. Okay, so I got sine, and then I'll put 60. Okay, so sine 60 gave me 0.866. So that's 3 decimal places, 0.866. So my answer for this would be 0.866. So this is basically equal to 0.866. Okay. Now I want y'all to try cosine 40. So cosine 40. Let's see what you get for cosine 40. So remember, when you put your answer, you have to put it to 3 decimal places. 0.766. Why? Is anybody else get anything different? So let's see. Let's make sure that we do our proper rounding as well too. So cosine 40. So 0.766. So therefore, I would have here 0.766. So the third one, I want y'all to work out tan 25 degrees. Let's see what y'all get for that. Tan 25 degrees. So tan 25 is 0.466. This 3 is too small to raise this to a 7. In order to raise this to a 7, it needed to be 5 or more. So we have to keep 0.466. Alright, so the next one that we're going to do are the ones that give the angles. So these give the angles. So these are going to be the inverse. Anytime you want to calculate the angle, you'll end up using the inverse. So for instance, sine, and it goes to the power of -1. Alright, so let's see if we use these same values here. So you could kind of see roughly you're going to get close to that number. So sine inverse 0.866. 0.866. Now the question is, how do we get this inverse thing? So on your calculator, what you would end up doing is you would end up pressing shift then sign. Okay, you press shift then sign. If you don't have shift, you'll probably have second. So you have a little 2 and an ND. So like on this one here, you see this one has shift in the corner. This one has shift in the corner. And on this one had second. This one that says 2 and then ND. 2 ND. So once I press shift and then sign, it should give me this with a -1. So this -1 just means the inverse. So sine inverse. So sine inverse of 0.866. You see what it gave me? 59.997, which is basically close to 60 degrees, right? So I could say 60 degrees. Okay, so usually we put these to 2 decimal places, but since 60 is going to be a flat whole number, I'll put it as 60. So I'll do a different one for you to try now. So let's say we had 5 being cosine inverse for 0.543. Let's see what you get for that. And then for tan inverse, let's see what you get for 0.825. All right. So 1 gives us the trigonometric ratios. So this version. So we press sine, then the angle, cosine, then the angle to get the ratio. And then to get the angles, we use the inverse, and then we put in whatever value we get as for the ratio. All right, so work this out, and then after we'll try to go into now how to use the formula for each trigonometric ratio. So let's see what y'all get for these. All right, so what y'all got for number 5?
57.111.
All right, so we said cosine inverse of 0.543, which gives us 57.11. Okay, so that means this is our angle, 57.11 degrees. What did we get for the next one here? We use shift and then tan, so we get 39.52. So 32.52 degrees. All right, everybody got that?
Yeah.
Okay, wonderful. So what we're gonna do now is combine these two skills that we learned. The first skill was identifying the opposite, adjacent, and the hypotenuse. The second skill was using the trigonometric functions and their inverses. So this is a trigonometric function that gives us the ratios, and then this is the inverse of those trigonometric functions, which give us the angle. Now we're gonna put 2 of these skills together to basically use these formula here. All right, so the first scenario we're going to talk about is when we're trying to calculate the angle. So let's say we have the first one, and these are used for what kind of angles? Triangles, sorry. Right angle triangles, right? So we want to figure out what this angle here is. And let's say here is a right angle, and right here we have 8 centimeters. And let's say that the length down here is 6 centimeters. So we want to calculate the missing angle that we are looking at. So this is our angle of focus. Now, using the opposite, adjacent, and a hypotenuse, what 2 do we have? So I'm looking at these 2 and I'm trying to figure out what 2 do we have. So this 8 represents what? What is this 8? Opposite, hypotenuse, or adjacent? The opposite, because it's opposite the angle that we are looking at. So this here is the opposite. So if that's the opposite, what this one would have been?
Hypotenuse.
Good. So what is this here?
Adjacent.
Adjacent. So we have 2 things now. This is the exciting part. This is how we connecting all the stuff. So we have here opposite and we have here adjacent. Now back to one of the first questions I was asking y'all before we started anything. What uses O and A? Sine, cosine, or tan? What uses O and A? Tan. Excellent. So that means I have to use the formula tan angle is equal to opposite, or O, over A. Y'all follow what I did there just now? So I identified what 2 do I have. The 2 lengths I have would be the opposite and the adjacent. There are cases you could have all 3 lengths. So if you have all 3 lengths, you could do other stuff as well. But right now we only have 2 lengths, which would be 8 and 6, which represent the opposite and the adjacent. Therefore, O and A would be here because this has a O and this here has a A. So that means I'm using tan. So I'm trying to find the angle. So tan angle, I don't know what that is right now, is equal to this ratio here. And what's a ratio? Opposite over adjacent. What is the opposite? 8. And that goes over the adjacent. What's the adjacent? 6. Okay. So 8 is the opposite. 6 is the adjacent. Now, all I need to do now is divide these two numbers. So 8 divided by 6 gives me 1 point, and I do it to 3 decimal places. 3, 3, 3. I always do these ratio parts to 3 decimal places. So 1.333. So how did I get this? I just put in my calculator 8 divided by 6. Y'all follow that?
Yeah.
Now, what am I trying to calculate here? The angle. So once you are trying to calculate the angle, okay, based on what we looked at last time, when we calculating the angle, we use the inverse. Okay, so these give us the angles. When we are trying to find the angle, we use the inverse and then the ratio that we got. So the ratio that we got was 1.33, so I have to use tan inverse. Okay, so tan inverse 1.333, and that's gonna give me the angle. So the angle is what? Based off of this, what is the angle? What is the angle? 53.12. So we went on our calculator. We have tan inverse here. So we have 1.33, which gives us 53.12. And because this 3 is less than 5, we don't need to bump this 2 up. So we say our angle is 53.12. So now when we get the angle, we put it to 2 decimal places unless they ask us otherwise. But once we have these ratios, we put the 1.33. Okay, so essentially we just combined the skills that we were practicing just now. So the first skill we were practicing was how to identify opposite, the adjacent, and the hypotenuse. And then the next thing we were using was how to use tan inverse and tan. Now in this case here, we end up using tan because the two lengths that we had were the opposite and the adjacent. All right, does that make sense? All right, so let me give y'all a next one. This time y'all gonna try that and we're gonna go through it together. So the first thing you have to do is a skill that we have been practicing earlier. What is the opposite? What is the adjacent? What is the hypotenuse? Then which ones are we actually focusing on? Which ones are we actually looking at? So we are trying to calculate here the angle. So we want to get this angle. So we're calculating the missing angle of a right-angled triangle. So let's see what you come up with for this. Remember, the first thing we have to do is identify what do these two lengths represent. And once we figure that out, we can figure out which one of these can be used, and then we could get into calculations. All right, so try to do this one. Make sure you ask yourself when you're going through it, what is this? Is this the opposite, and why is it the opposite? Is this the adjacent, and why is it the adjacent? Is this the hypotenuse, and why is it a hypotenuse? Just to make sure you got that part right, and then you move on to working it out. So let's see what y'all got for this now, right? So the first thing I'm gonna do is try to identify this. So this here, this 12, what does this 12 represent? The hypotenuse. What does this 5 represent? The opposite. What uses opposite and hypotenuse? Sine. So then I'm gonna say for this one, sine theta is equal to O over H, because O and H comes from sine. So therefore I could say that sine angle is equal to 5 over 12. So now what I need to do is divide 5 by 12 and see what I get. So 5 divided by 12 gives me 0.416666 and so forth. So the thing is, because of this 6 here being more than 5, I'm going to round that to 7. So therefore, I'm going to say that this is 0.417. So now I'm trying to calculate the angle, so I have to do the inverse sine of 0.417, and this is where you need to be careful, because sometimes when you're doing a calculator you might mistake and press cosine or tan instead of sine, so you just got to make sure that you press the correct one, right? So sine inverse 0.417, we get 24.64, but look at this 5. This is 5 or more, so this 5 means that we have to round this 4 up to a 5, so I'm gonna get 24.65. 24.65. So the important thing for you here is that I want you to be able to catch the concept of how we get to this. The little rounding and those kind of stuff are minor things as it relates to this, but being able to understand this concept and how we got from here to here is the important part. All right, so I'll give y'all one more like this to try, and then after we'll go into the actual calculation of the lengths now. Make sure y'all working on trying to get the calculations and the practice in the process. It's very important. So let's look at the third one here. So the last one for this kind of step. All right, so we're trying to calculate the angle here. So let's see what y'all will come up with for this one.
Teacher, I have a problem here.
Tell me.
When I divide the 9 over 15, right, and I get that answer, when I try to press the reverse cosine, however, it's showing me that like an error, showing me the answer.
You know why? So you telling me that when you divide that you getting that, right? So the problem is you're probably actually putting 15 divided by 9 in a calculator instead of 9 divided by 15.
Oh, okay.
All right, so let's go through this one quickly. So this here, what does this 15 represent? The hypotenuse. All right. What does this 9 represent? The adjacent. Okay. This is the adjacent because here would have been the opposite. So therefore, this here is the adjacent. Make sense?
Yeah.
So what uses A and H? Cosine. Excellent. So cosine, which gives us A over H, is what we will use in this case. So A over H. So A is 9. So 9 over 15. Now remember, once we do this division part here, we want to use 3 decimal places. Okay? Always remember to use 3 decimal places. So 9 divided by 15, and that's in some cases we may not be able to, but in this case 0.6. So just to remember the proof of concept, I'll just put it like this for now, just to remember this. But in this case 0.6 is a flat number. That's what we're going to use. But remember, typically we practice using 3 decimal places. Does that make sense?
Yeah.
All right, so now we have to find an angle. So we find the inverse. So we say inverse cosine on -1 here would give us, what would the answer be? Cosine inverse 0.6 gives us 53.13. So here would be 53.13 degrees.
So, okay, you see how you had 53.13, right?
Mm-hmm.
If the number after that 13 there was like 5 and up, you could run it out?
Yeah, I would have rounded to 4.
Oh, okay.
Mm-hmm. Good. All right, so we got that. That's how we calculate the angle. The next thing we have to work out now is when we are doing the length. So there are 2 scenarios that we have to when we're doing the length. We're going to look at the first one, which is when the numerator is unknown. Okay, so when the numerator is unknown. All right, so let's look at our first example now. These are for right angle triangles. So we're going to have this triangle here. So I'm going to say this is 32 degrees. So this is the angle we want to focus on, the 32 degrees. Okay, 32 degrees. And I'm going to say that the length here is 16 centimeters. And then what I want to calculate is going to be this line over here. So my question is, if I want to calculate this, I need to figure out what this length that I have is. What is this length? This 16 represents what and why? This here is the hypotenuse. And I know it's a hypotenuse because it's exactly, it's opposite from the right angle. Now, what is this one that we are trying to figure out? What does this question mark represent? The opposite. So here is the opposite because it's opposite the angle that we are looking at, which is 32. Does that make sense?
Yeah.
Everybody understand that? Yep. Good. So who uses O and H? Who uses O and H? Sine. Excellent. So I could say now that sine angle is equal to opposite over hypotenuse. Now, this time I know what the angle is. What is the angle? 32. So I can say sine 32 is equal to O. I don't know what O is. So O is going to be there, which represents the opposite. So don't confuse it with 0. So O is the opposite, and that's over H, which is the hypotenuse, and the value for that is what? 16. Good. Everybody understand what we did here?
Yes.
So we're repeating the same process over and over. So this is the thing now. So sine 32. Sine 32. I need to figure out what is sine 32. So all I have to do is do what? Put this in the
Calculate.
excellent. So sine 32. And we're going to put this one to 3 decimal places. So we have here 0.529 and then a 9. So that means this 9 is going to make this turn to 0 and this is going to turn to 3. So this is going to be 0.530. All right. So I know that here is going to be 0.530, which is equal to O over 16. Now, before I continue, I want to make this number a fraction. And now to make any number a fraction, what do we have to put it over? What is 10 as a fraction? 10 over 1. What is x as a fraction? X over 1. So what do you think 0.530 as a fraction would be?
0.530 over 1.
Exactly. So 0.530 over 1. I'm making this a fraction because I want to do something we call cross multiply. Okay, cross multiply. So I didn't do anything hard here. All I did is sine 32, put that in a calculator. I got this. I'm just writing this back over and over. And I just wanted to make this a fraction so I can cross multiply. What do I mean by cross multiply? I want to cross multiply. So this times this would be equal to this times this. That's why I call it cross multiplication. So in that sense, I'm going to say 0.530 multiplied by who? 16. And then the O is going to multiply to who? The 1. Good. This is O, guys, not 0. O, the letter O. So 0.530 times 16. Okay, remember we cross multiply. So I'll just put this here so we could remember. So the cross multiplication. So 0.530 times 16 gives us what? 0.530 times 16 gives us what? 8.48. Nice. So 8.48. All right. And remember, this here is a O. So this O times 1 is actually O for opposite. Okay, remember this here is O for opposite. So 8.48 represents the opposite. So in this case, we know that this here is actually the length of 8.48 centimeters. All right. So this is a process that we use when this one here at the top is unknown, when we do not know what the value at the top is. So this same concept applies for when we don't know this one at the top here, neither this one at the top here. All right. So this here is a process for that. So as you can see, we had one angle that we were focusing on, as well as one length, which ended up being the denominator. So I'll give you all one to try now. So the same process applies. We're just repeating the same process over and over today. What is the opposite? What is the hypotenuse? what is the adjacent? Okay, good. Once we got two we're looking at, okay, so we got those two. So who do we use? Sine, cosine, or tan? Same thing over and over. So here now, my angle that I'm looking at is 40 degrees. And then I have here 12 centimeters. Now, what do I want to calculate? I want to figure out what this here is. All right, so I want to figure out what this length here is. All right, so let's see if y'all can figure out what this here is. All right, so remember, we're in the phase of calculating the length when the numerator is unknown. Once we do that, we'll check to do what it is when the denominator is unknown. And that would be the last phase of this particular concept. So everybody use what ones y'all use? Cosine, tan, which one?
Cosine.
Cosine. Everybody use cosine?
Yeah.
Nice. This isn't so bad, right? Not so bad.
Nah, it's good.
Good. So after when I show y'all the other one, what's gonna happen is once you practice these things now, the practice is gonna force you to figure out how to combine all these skills that we learn to answer a particular question. All right, so let's go through it quickly, and then we do the last part when the denominator is unknown. So this one here, 12. 12 represents the hypotenuse. We are trying to calculate this over here, which is the adjacent. Now, how do I know this is the adjacent? Well, I know that this here is the opposite. So if here's the opposite and here's the hypotenuse, this has to be the adjacent. So A and H, what uses A and H?
Cos.
Yep, so cosine uses A and H, right? So then A represents this and 40 is theta. So cosine 40 is equal to A over 12. So when I put cosine 40 in the calculator, I get 0.766. So then I could say 0.766 is equal to A over 12. Now, we have to make this as a fraction. How do I make this as a fraction?
0.766 over 1.
0.766 over 1. And that's equal to A over 12. So all I have to do now is cross multiply. So then that would be 0.766 times 12, which is equal to A times 1. So therefore this one here is what?
9.192.
So 9.192. So I'll use 9.19 to 2 decimal places. So therefore I know that adjacent is 9.19. In other words, here is 9.19 centimeters. So then the final scenario now, when the denominator is unknown. So this goes in levels, right? So the first scenario would have been the easiest one to do. Second scenario is the next one. And then third one is the one that will give you the most challenge, which isn't hard. It's following the same process, but we just need to do an extra step. In this case, the denominator is unknown. So the first question we will do with this one, with this kind of scenario, and we only know these scenarios after we set up the question. So our question mark is going to be for this right here. Our angle is going to be right here. We're going to say this is 34. And then this here is going to be 7 centimeters. All right. So this here represents what?
The hypotenuse.
The hypotenuse. So that's what we want to find, the hypotenuse. What does this 7 represent? What does this 7 represent?
That's the opposite.
Exactly. How you know it's the opposite? No.
It's opposite to the angle.
Exactly. So it's opposite to the angle that we're looking at. So O and H. Who uses O and H? Josiah, who uses O and H? Sine. So we say sine angle is equal to O over H. So then sine 34. What is sine 34? So we have sine 34. We know what the opposite is, which is 7. We don't know what the hypotenuse is, so our denominator is unknown. Sine 34, what you get for that?
0.559.
So 0.559 7.59. Nice. So that's equal to 7 over h. Now the next thing that we do, we put this as what? A fraction, so it would go over 1. So it's the same concept. And then we do what from here? Cross multiply again. Same process. Nothing changes. The only change will come in a little bit. So we'll have here now 0.559 multiplied by h, which is 0.559h, and that's equal to 7 times 1, which is what? What's 7 times 1? 7. Nice. So 7 times 1 is 7. Okay? Now, I'll write this back because this is the extra step that we're going to have. So we're trying to find h, which is equal to 7. Now, 0.559 is being multiplied to the h. We need to get h by itself. So if I'm multiplying by the h, what is the opposite of multiplying to h to get it by itself? We divide, right? So divide both sides by what's next to the h, which is 0.559. So we're going to divide both sides by 0.559. Now, once we do that, we'll get the value of h, because as you can see here, all these cancel, so h is by itself. So therefore, h would be equal to 7 divided by 0.559. So 7 divided by 0.559 gives us 12.52. So I can say that the hypotenuse here is 12.52 centimeters. All right, so I want y'all to take this down. So basically here we do the same process. The only difference is that when we come here, we end up dividing. Usually in the other step, we stop right here. Okay, in scenario 2, we end up stopping right here. But with scenario 3, we have a few more extra steps in order to figure out what the denominator is. Okay, so what I want y'all to do now is try to work out this one. So this is the last one we look at for y'all to try to do, and you know the process from here. You'll get a practice activity, so y'all could probably work on that in the next few days. So I expect to see it done. So you'll just show me what you do, even if you show me 2 questions at a time or whatever the case is. So we want to figure out what here is. All right, we want to figure out what this represents. Okay, and we have this. So the question is, what does the question mark represent? Opposite, adjacent, or hypotenuse? Then you have to figure out what the 5 represents. Then you try to do the process by identifying which one to use and then calculating that length. All right, so take a shot at this, see what you get. All right, so Josiah, walk me through this one, Josiah. So Josiah, what 5 centimeters is? The adjacent. And what is this one here? Hypotenuse. What uses a and h? All right, so cosine angle is equal to a over h. What is the angle?
50.
So 50 is equal to a, which is 5 over h, which we don't know. So what is cosine 50? So cosine 50 is 0.643. You following me? Which is equal to 5 over h. So what am I supposed to do next? So 0.643 over 1, which is equal to 5 over h. What's the next step? You cross multiply. So this here we get 0.643h, which is equal to 5 times 1. How do we get the h by itself now? We divide. So we divide both sides by 0.643. Okay? So therefore, the hypotenuse is equal to 5 divided by 0.643. So if I do 5 divided by 0.643, I would get 7.78, because this 6 would allow this 7 to turn to an 8. Alright, so therefore this would be 7.78 centimeters. And that's our answer. Does that make sense?
Yeah.
Alright. So I'm going to send y'all some stuff to try and practice before our next class. So make sure you get this part done packed. The next one we're going to use is a different kind of rule and a different kind of concept. So make sure you got this done packed. Okay? Make sense? Y'all understand what we're doing? What's doing?
Yeah.
All right, good. All right, so you guys have a good night.